Hello guys.
Good morning guys.
Hello. Hello po. May absent ba?
Late lang ata. Alam ko papasok sila kasi may reporting tayo ngayon, di ba?
Uli, ready na ba kayo sa mga report nyo?
Grabe, kinakabahan ako mamaya sa reporting.
Nandiyan na si ma'am.
Good morning, class.
Good morning po, ma'am.
Good morning, ma'am.
Hello po, ma'am. Good morning.
So, I believe you have prepared a presentation for today.
Yes po, ma'am.
Yes po, ma'am.
Yes po, ma'am.
Good. But before that, let's have a quick recap about our topic last time, which is about convection. So what is convection? Convection is a transfer of heat related to the movement that occurs within a fluid due to the rising of hotter materials, paired with the sinking of colder materials. This occurs because the hotter materials are less denser than the colder materials. So a perfect example for that is a water boiling in a pot or in a kettle. So the heat rises up as well as the hotter material or the hotter water because it is less dense, while the colder water or the colder material goes downward because it is more dense. So there will be a circling motion or a circular motion in convection. So here is a perfect example for that.
Now, if we're talking about the convection in geo, convection also happens in the mantle, which causes the movements of the plates.
Okay, now I believe I have assigned students to present for today's topic.
A convergent boundary, also known as a destructive boundary, is a region on Earth where two or more lithospheric plates collide. The stress of rocks acts upon this convergent boundary is called collision. What the Benioff zone can describe the subduction zone is a plane where many earthquakes happen. One plate gradually slips under the other, creating a mechanism known as subduction. But there are times where they don't subduct, especially under convergence of continental to continental plates that will be discussed by my groupmates. May I present to you, or may I call Crystal Mayano, Tiffany Beneros, and Stephanie Merto to further discuss about the different subtypes of continental convergence.
I will be going to discuss the continental collision. But first, what is a continental collision? Continental collision is a phenomenon of the plate tectonics of the Earth that occurs at the convergent boundaries. Continental collision is a variation on the fundamental process of subduction, whereby the subduction zone is destroyed, mountains produced, and two continents adhered together. How does it look like convergent continental to continental? Continental crust is too buoyant to subduct. If the two plates that meet at the convergent plate boundary both consist of continental crust, they will smash together and push upwards to create mountains. Large slabs of lithospheres smashing together, creating large earthquakes. What happens when two continental crusts meet? Plates collide when two plates carrying continents collide. The continental crust buckles and rocks pile up, creating towering mountain ranges. Example of it is the Himalayas. The Himalayas were born when the Indian subcontinent smashed into Asia 45 million years ago. Thank you.
In collision between two oceanic plates, the cooler, denser oceanic lithosphere sinks beneath the warmer oceanic lithosphere. As the slab sinks deeper into the mantle, it releases water from dehydration of hydrous mineral in the oceanic crust. Melting of mantle material creates volcanoes into the subduction zone.
Now, I'm going to discuss the convergence of oceanic and continental crust. In this type of convergence, it is important to know their densities. Why do you think so? Because it gives us an idea on which crust will subduct, as the fact that we know that the denser crust will subduct. Let us first find out their densities. Oceanic crust is made up of basalt. It is thinner but denser than continental crust. While continental crust is made up of granite, it's thicker but less denser than oceanic crust, which results the subduction of oceanic crust. Reduction of oceanic crust results to trenches. Trivia time! Trench are the deep depression in the ocean floor. Have you ever heard of Mariana Trench? Well, if you do, that's good. Mariana Trench is the deepest trench in the world, and the deepest part of Mariana Trench is called Challenger Deep.
Okay, what a great presentation for your group. Let's give them a round of applause. Now, next, please proceed with the second group.
Divergent boundary is a linear feature that exists between two tectonic plates that are moving away from each other, and this occurs above rising convection currents. Divergent boundary are consecutive boundaries because new crust is formed as the plate moves apart. Magma fills in the gap and creates new crust. And there are two major types of divergent boundaries: the continental to continental lithosphere and the oceanic to oceanic lithosphere.
Hello everyone. I'm going to discuss the divergence of continental to continental crust. In this type of divergence, two continental crusts separate. But how does it happen? As the magma on the mantle rises, its magma makes the continental crust thinner and thinner until it breaks and they separate from one another. This explains why it is hotter in the middle of a rift. What is a rift? Rift is formed by two divergences of two continental crusts as they separate. It forms a path like on the surface. One of the known rifts is the East African Rift System, which extends northward to the Red Sea and eastward into the Indian Ocean.
Hello everyone, so the assigned topic for me is all about the oceanic to oceanic divergent plate boundary. So oceanic to oceanic divergence is a divergence of plate boundaries of oceanic plates. So when oceanic plates moves apart or moves away from each other, the magma rises from the mantle until it solidifies and cools and forms a new seafloor, which is called the seafloor spreading. And this seafloor spreading forms a mid-oceanic ridge, which is the central ridge structure that divides the ocean basin in half. So the new formed rocks that are closest to this mid-oceanic ridge are younger than those further away. So I'll give you an example of this mid-oceanic ridge, which is the Mid-Atlantic Ridge. So Mid-Atlantic Ridge was formed because the North American plate and the Eurasian plate diverge, creating a fault. And it creates a bridge where the magma can escape and it cools and solidifies for a very long time. So after this very long time, or for a long period of time, the solidified and cooled magma builds up on undersea volcanoes and eventually grow above sea level. So that's all about my topic.
Okay, so the second group presented well also. So now let's proceed with the next group. I hope you two will present as much or as well as the first groups.
Transform fault boundary is a type of strike-slip fault wherein the relative horizontal slip is accommodating the movement between two ocean ridges or other tectonic boundaries. A transform fault may occur in a portion of a fracture zone that exists between different offset spreading centers, or that spreading centers to deep sea trenches in subduction zones, which may result to shallow earthquakes, large displacement of rocks, and crustal deformation. And the most famous example of this is the San Andreas Fault located in the western North America, and the transform fault boundary inland, that is the Alpine Fault in New Zealand.
Okay, now I want to give all of you a round of applause for presenting and giving your best and effort in today's presentation.
Goodbye, ma'am!
Goodbye po, ma'am!
Thank you po, ma'am.